morning everyone. I'm Yashashwini from cybersecurity and I'm here to explain a topic about transaction management. So first of all, let us know about what are the properties of the transaction. So in database management system, transaction properties refers to the characteristics or qualities that transaction must exhibit to ensure data integrity, consistency and reliability. So let us see what are those characteristics of the transaction. So these properties are typically defined by ACID properties. So commonly we will call the transaction properties by the name ACID properties. So the first one is atomicity, second one consistency, third one isolation, and the last durability. So let us see in detail of each. Atomicity. Atomicity ensures Atomicity ensures that a transaction is indivisible or all or nothing. So, in other words, either all the operations within the transactions are completed successfully or none of them are. There is no partial completion. So, in atomicity, overall, all the operations which we want to perform or completely successfully completed. So no, there is no chance to partial completion. So let's see an example. For example, consider a bank transfer where money is withdrawn from one account and deposited into another account. So atomicity ensures that if for some reason the deposit operation fails after the withdrawal, has occurred, the withdrawal is rolled back and both accounts are left unchanged. So, in the middle of any transaction, if there is a possibility of fails the operation, so there is no change in the both of the accounts. So, this is called the atomicity. So the next one is consistency. Consistency ensures that a database transitions from one consistent state to another consistent state. So there is a consistent transaction between two accounts after a transaction is executed. So in other words, transaction must adhere to all the rules and constraints. So it must follow all the rules and constraints defined by the database schema. So schema defines overall database structure, right? So in that, the transaction must follow the rules and constraints of that. So if a transaction violates all of this constraint, it is aborted. So if there are any operations or a transaction omit these constraints or the rules, so overall the transaction is aborted. So and the database remains unchanged. So because it is aborted, so there is no change in the database of any accounts. So for example, consider a database where a certain column must always contain unique values. If a transaction attempts to insert a duplicate values into this column, it violates the uniqueness constraint and the transaction is aborted to maintain the consistency. So in this example, for a certain column, we given the constraint as a unique value. So there is no allows of duplicate values into the column. So if we try to give any duplicate value, the repeated value, so it violates the uniqueness constraint. So it is violating the rule of the consistency. So it is the transaction is aborted to maintain the consistency. So the next one is isolation. So isolation ensures that each transaction operates independently. So there is no dependency of the transactions to one each other. So it must be operates like independently of other transactions. So this prevents transaction from interfering with each other's execution and ensures that each transaction is a consistent view of the database. So we will not interfere or involve with other transactions and other accounts. So every operations of each transactions are independent. So they will not involve with the other transactions. So to maintain the consistency of the database, we are following the isolation rule. So for example, consider two transactions. Transaction A reads data from a table and transaction B updates the same data. So here we take in two transactions. Transaction A reads data from table. So it will read the data from the table, and B transaction does updates on the same data. So the data which is read from the transaction A, so we are updating in a transaction B. So isolation ensures that transaction A sees a consistent snapshots of the data, regardless of any updates made by transaction B until transaction A completes. So even though the transaction B updates the data which is given with the transaction A, but the transaction A contains the only consistent snapshots because there is no updated value is inserted into the transaction A. So because isolation is the main purpose of independent transactions, so they will not involve. So the next one is durability. Durability ensures that once a transaction is successfully committed, the changes it has made to the database are permanent and will survive system crashes or failures. This means that even in the face of power outages, hardware failures or the software crashes, the changes made by committed transactions remains intact and are not lost. So the transactions which are committed, even though there are some of the other external failures of the software or hardware, they will not change the transaction because already we have committed the transaction. So there is no loss of the data or anything in the transactions once it is committed. So due to that durability we have in the transaction properties. So for example, if a customer needs a purchase on and the corresponding transaction commits, the database must ensure that the purchase record persists in the database and is not lost even if the database server crashes immediately after the commit. So if we make a bill of one item, that means we commit the transaction to the company. Even though if the company's server is breakdown, so the record is committed already in the server. So there is no loss of the data in the server. So in conclusion, transaction properties in Dbms encapsulated by the ACID properties, which is extended as atomicity, consistency, isolation, durability model, ensure that database operations are reliable, consistent and recoverable with no loss of the data and no dependency of other data and independent data. So these properties guarantee that transactions are executed as indivisible units, maintain data integrity and adherence to constraints. So it will follow the constraints and rules of the database schema with the rule of consistency and operate independently of each other and preserve data changes permanently despite system failure. So even in the failure of the any system, the changes is permanently committed into the database. So and we cannot see the dependency of two transactions here, right? So it is independent of each other. Thank you.